When we hop in a bomb, we get these different levels, right? Level 1, level 2, level 3, level 4. We always want to keep in mind the 5 opcodes that we're interested in, right? One of them was calls. So immediately my mind goes to these calls, and I see these different levels, right? So we can start at level 1. Level 1 is very simple because it ends up just calling a string compare. And we know anytime we're doing some type of comparison, it's just going to be whatever this is over here compared with whatever our input is, likely, right? So if we pop over to AWS real quick, let's hit OK, and we will drop down over here. So bomb plus x bomb / bomb. So the first one is looking for the answer of the code never bothered me anyway. So I'll copy that, paste it there. Awesome. So we got to the second level. All right, not too shabby. Let's try something else, and then now we're on level 2. So level 1's pretty easy. Level 2 is when it starts to get harder, but we can see it says call read 6 numbers. Right, so we know that it's going to be reading 6 numbers, and it's going to be comparing them. It's going to be comparing all 5 of them and going through a loop here. Right? So we can look at this. We can see that it has some type of move, subtract by 1, then we're going to multiply, then we're going to move, and then we're going to compare again. And if we don't get it right, we're going to call explode. So what's the best way to deal with this? Right? We see this comparison here. We can take this address, and we can take bomb, and we can say gdb /bomb. Oops. And we'll say break star 0x. Cool. We'll hit run. And we'll say the code never bothered me anyway. And I messed up. Why? Because I put a space at the end. And hopefully I didn't spell something wrong. Let's try to run it again. So we know it's saying input 6 numbers, right? So we do 1, 2, 3, 4, 5, and then 6. Cool, and then we hit this breakpoint in level 2. So we can see that on this breakpoint of this compare, it's comparing EDX to EAX. Right, EDX to EAX. So if we do IR, EAX is 2, EDX is 3. What was our input? It was 1, 2, 3, 4, right? So we can assume that if our input is 1, our second input should be 3. So if we run this again, and we say the code never bothered me anyway, and we do 1, 3, 4, 5, 6, 7, and we do an IR. Now 3 and 3. See how quickly we deduce that without doing any reverse engineering of what it wants for input? Just by looking at those top 5 opcodes, right? We only looked at calls and compares so far. We haven't looked at anything else besides the calls and compares. Right? We looked at calls, we said it reads 6 numbers. And then we looked at this compare down here to figure out what those 6 numbers were.
So it's storing it as an array of both.
Yep.
And it references the index.
Yes, in this case. And it's going through that loop, right? So now we're comparing 3 to 3. So we go to the next. And now we see our input was 4, but instead it's expecting 12. Right? That's interesting. So we could set $EAX equals 12. And now we can continue the program. So we know it should look like 1, 3, 12. We do an IR again. We got 5 and it's looking for 20. Right, now we can set $EAX to 20 again. Cool. Then we can continue again. IR. Now it's looking for 30. So we can do the same thing. 30, continue. Now it's looking for 42, 42, and that looks like 6 numbers. So we can set 42, and we'll continue. And now it says, I see you're very well versed in mathematics. Right, so we got level 2 very quickly just by inspecting that comparison. Right, very, very quickly. So we're gonna end that, and we're gonna run it again, and we're gonna start over. And we're gonna say this, then we're gonna say this, whoops. Run, no, we're gonna disable 1. So we disable that first breakpoint, so we're not bothered about it anyway, just to make sure our program still works. Cool, code never bothered me anyway. 1, 3, 12. Oh, that didn't work. Right? That didn't work. So let's go back. Let's enable 1 again. And we know that if we run it, and then the next one should be this. Cool, IR, that's right. IR, that's right. IR. Oh, it's 60 all of a sudden. So we want to be careful when we're making changes directly to the program, because the program might not function anymore based off of our changes, right? So now instead of saying, okay, our next input should be 60, right? And now we're gonna have to run it again. And we'll check it again. IR, 3, good. IR, 12, good. 60, good. Now it's looking for 360. Are you guys starting to see a pattern here?
It's modifying based on the previous input,
Modifying on the previous input.
or the previous number.
Somehow, yes. That's exactly right. So now we just need to get the last number. Anyone want to take a guess as to what the last number is going to be? 360 times 7? Ooh, interesting. 360 times 7. I like that. Good. 2520. 2520. Let's see if that worked. We'll restart the program. Hope never bothered me anyway. Cool. And let's see. Boom, we're good on that one. Good on this one. Good on that one. Good on this one. And the moment of truth. Times 7. Right, so we're able to formulate a pattern there now. So it was this times whatever, times whatever, times whatever. Who here understands algorithms very well? We've got at least one student. He knows times 7. That was pretty good. So yeah, cool. So now we definitely got level 2 and we're on to level 3. Alright? So
How do you figure out it was times 7 on the next one?
he did math.
Oh yeah, so if we go back,
It was 60 times 6 makes 360. 12 times 5 makes 60.
Oh,
3 times 4,
it changes the multiplier by +1.
something like that, yeah. Yes, exactly. But I don't know how the first one works. That part doesn't make sense, yeah. We're not gonna worry about that. But you guys get made 2520, which is exactly right. So cool. So now we have 2 lines. We're doing pretty good. Going through this kind of fast. Any questions so far? Alright, class. Let's look at level 3. So level 3 says we're gonna input, but your input's gonna be %D, %C, %D. Did anyone figure out what these percents mean?
It's like a digit and character.
Yes. Yes, exactly. Right, so %D means decimal, %C means character, and %D means decimal again. So if we look up scanf, this is called a format string. So scanf, represents a specific pointer, and then we can see what the format should be. So in this case, a D should be a decimal integer, and a C should be a single character. So what we're looking for is a decimal character decimal. And then we have N, and we can right click this and change it to a decimal of 110. Then we have the character N again, which is kind of interesting, which should be 110 again. And we have another character here of O, which should be 111. And we have W. So what we want to do is figure out which one of these doesn't call explode. It's going to be very important, right? And if we look, it's coming down this way. So we're going to move var 11 into EAX, and then compare that with what looks like 110. And then we do the exact same comparison without moving anything. So it's jump if 0, jump if greater, and then jump if 0. So what this is telling us is our first input cannot be greater than 111, otherwise it goes down here. And cannot be greater than 110, and cannot be 111, right? And then we see a W, right? And then we have a 105. But this is also comparing the same character. We're never comparing the third character here. That's kind of confusing. But all of these paths here go to explode. Do we really care about the stuff that go down to explode? Shouldn't, right? Shouldn't really matter. So what we can do is we can input some stuff. And then we can set a breakpoint at these different comparisons. So we'll set a breakpoint at this one. Da-da-da. And then we'll set a breakpoint at this one. Same thing. And another breakpoint here. Same thing. And then another breakpoint here, because this is all the path to the right hand, right? So how much of the actual code am I figuring out here? Not very much, right? Notepad plus plus. Boop, 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 slash r slash n, break star 0x, and that should be the first. Awesome. Now we can paste this all as one command. Should be a lot easier. Whoops. All right. Now we just got. We're gonna delete all of our breakpoints. Delete 1 through 12. Cool. Awesome. Now we got a whole bunch of new breakpoints. So we're breaking out these different locations. We can run the program again. Input our two things. As long as we do it like that. Cool. We got our inputs. So it was saying decimal something something. Right? So we're going to say decimal 1, 2, 3, 4. And then we're going to put a character of A. And then we're going to say decimal 5, 6, 7, 8. Oh, it blew up. Blew up right away. Did we miss a compare here? I think we did, huh? Oh, we missed this compare. Come on. I'm gonna put some put up one. Cool. Run. Drop our input. Oops. Cool. We said 1, 2, 3, 4, A, and then 5, 6, 7, 8. Great, so now we break that first place. And let's inspect our values. So we have 1, 2, 3, 4 And what is it comparing itself against? Right, if we look at this very first break, EAX to 929. 929. Right, so our first input should be what? 929. Right? So we can set $EAX equal 929. IR looks good. We can continue. We didn't explode, that's a good sign. So now we're here, we want to look at what our EAX is. Our EAX is 0x61. What does that mean? The letter what? The letter A. W's a little far ahead. But it's the letter A, right? Because 0x61 is a lowercase a. That's what we input as our test string, right? Just the letter A. So cool. But it's comparing it to 110, which is n. So if it is an n, it's going to go this way, which is bad. So we don't want it to be an n. And we want it to be less than an n. Just kind of interesting, because if not, it goes down this way. Because if EAX is greater than n, we'll go down this way. Oh no, we'll go this way, sorry. JG, green. Alright, follow the green path. Cool. So if the letter is an O, that's no good. And we want it to come down to here. If it's a W, jump not 0. So ultimately, we want it to end up becoming a W, right? Or the hex value 77 or 119. So we can set our EAX again to 119. Is that right? 119? Yep. Cool. And we will continue. Great. So now we're on the last breakpoint. And this one is looking for another number. We input 5, 6, 7, 8. Ooh. Didn't change. What should change? What breakpoint are we at? Ah, I see. We haven't gone through all the breakpoints yet. So we must be 8 to E must be this one. 8 to E is this one, so we gotta continue one more time, and then continue again. So now we end up over here, IR. So now we're at that W, and we should be at line 83F. We're at 83F, so that's good. So now we should be able to continue. We didn't explode. And now we can look at our EAX again. And our 5, 6, 7, 8 should be compared to 1105, right? So our answer should look something like W1105, and the first one was 929. Cool. Let's try these three. So we'll run the program again. Disable 1 through 100 and continue. Cool. We're halfway done. Is this tracking? Yeah? Sure. Awesome. So we're on level 4 now. Level 4 is just a %D. And then there's this mystery function. Right? If we go into the mystery function, it just keeps calling this mystery function. Calling the mystery function. And sometimes it returns something. Right? At the end of it all, we're expecting to compare AL with 233 somehow, right, within this mystery function. Should we go in there and figure out what this mystery function does? We could. Or we can just look at this compare and set a breakpoint, which is what we're going to do. So we're going to delete 0 through 100, break, star, 0x. Cool. And we're going to run. Copy this, hit yes. All right, so now we're halfway done. It's saying that it wants a decimal of 233, but that's before the function, so we'll see what it is. We see that it's pausing here, right? I didn't pause it, it just is paused. So we're waiting, waiting, waiting. Nothing's happening. Really waiting for this function, eh? Wow. Wow. Should we have started with 233? Probably not, right? Let's start with something simpler. Let's hit run again. Let's go yes. Cool. Halfway done. Let's start with like 3. Ooh, it ran a lot faster, right? IR. EAX is 3. AL is only 3. That didn't work out. Okay. Let's run it again. Let's try 4 this time. Let's try 4. IR. EAX is 5. Kind of interesting. Last time we entered 3, it ended up 3. We entered 4. Now it's 5. Something weird's going on here. Start it again. Let's try 6. Now we got 13. So 6 becomes 13. Right? Some type of recursion or something going on within this mystery function that brings back values. Right? It keeps calling itself, calling itself, calling itself. When we entered 233, it was probably too many times it recursed. So let's try 7. 7 becomes 21. Right? 6 became 13. Should we try something like 21 next? Yeah? That's way too much. But that's not AL. Does that make sense? EAX is not the same as AL. Right? AL is just this 2, just a 2F part. Right? So we're expecting it to be E9. So we can do this a couple different ways. We can figure out how the mystery function works, or we can try to brute force it. Right? All these are pretty good answers. I tend to like to brute force things. Cool. Let's try 20. Now we got C2. Let's try 19. That doesn't look right, right? We're looking for it to end in E9. Run. Where are we at? 18? No. 17? What did we just do? 17? 16? 3D. 15. Nope. 14. Oh. 14. 62. Not what we're looking for. 13. 79, that's no good. Good for E9. What did we do? 13? 12? Ah! We got E9. Cool, so we solved level 4. Is there a lot of other solutions to this challenge? Tons. Alright? So, but sometimes brute force is a good answer. Sometimes brute force is a good answer. So we did 4. Let's do 5. 5. We have this thing. BHDJEEKBY Pagina. Should we just try that? Why not, right? That didn't work. We know the answer to the last one is 12. Let's put that in our sheet. Cool. Run. Actually, let's take a look at this code. So, we have a call to string length. String length says that our string should only be 5 characters long. That's kind of interesting. We're going to iterate through this string. There's something here that says hyena. That's kind of interesting. And then we're going to do a string compare for hyena. And if it is hyena, we're going to call explode. Why don't we try hyena? Right? Continue. Hyena? Nope, that exploded. So there's something going on here, right? Something going on. If we take a look at this code, see that it does a lot of stuff. Does a lot of stuff. So, if we run it again, cool, continue, sorry. I want to take a breakpoint at this compare again, because that is what we do here. Break star 0x, IR, disable 19, actually, run, yes, cool, enter our input, oops. Grab it from our notepad to our desktop. Cool, this is getting a bit out of hand. We know it's expecting hyena, so let's try Athens. Because it should be 5 characters long, right? And then awesome. We will compare these 2 locations. So if we do x/s $EAX, we see hyen. And if we do x/x $, I think it's on EDX, we see an N. Let's see if we can look at ESP. Nope. ESP, EVP, EI, ESI, maybe? Nope. Let's see, where is it storing hyena for our reference? Level 5. Hyena gets set at ESP +4. So if we do x/10s $ESP, we see hyena there. We see hyen. That doesn't make sense. We're taking a look at this. We have this here. BDJEEK. Interesting. So we're adding over here, all this kind of stuff. Let's look at ESP minus 0x10. I see. X/S. Cool. So Hainan is located there, and we are comparing Haiyan. So somehow our input of Athen became Haiyan. So that's pretty close, right? Let's see if we run this again and do something else. Oops. Aina. And then x/x $sign EAX was our input. So we got HPE and H. Alright, for Aina. What happens if we take this into something like Shiver-Chef? And we do like a raw. You know that A comes back to H. Is there a brute force? We are looking for the output of HP and HH. Let's see if we can find anything. Nope, nothing. We're getting kind of closer, right? We have two pieces of information from this and what else did we have? We had Haiyan from Athens. Cool. So you see that the first A both times became an H, but the Y isn't always the same. Yeah? So it's not some type of static crypto here, right? It's something different. We're looking at something different here. So we know that H is right. Can we brute force this one? It's almost always the answer. It's almost always the answer. Cool.
26 characters for each.
What is that?
Well, you get 26 letters for each character, right?
You only got 26 letters for each character. Yeah, hopefully, hopefully.
Wow, that's good.
It could, it could. What does this have to do with it though? It looks like we have a key here. Some kind of key. Could it be like a Virginia cipher? What is that? Character map?
Yeah. The custom alphabet you give them and everything.
Character. I'm not trying. Let's try to be engineer. Put the code, Aina. No, that didn't come out. Alright, whatever.
Are you getting the same result?
It looks like I got FR Brew. Let's try encoder. Now I got FHU. Could be something like that though. Alright, could be something like that. You want to keep that in mind. So we'll come back down here. We tried Aina. T and Y made P, and we're looking for Haina. Haina. Alright, we're looking for Haina. So I got HP. Can't really go lower than Z. We try like 2 8s. AA 10. AA 10. Let's try that. I don't know. I messed up. Run paste. Oops. AA 10. Cool. $sign EAX is our input. Now we got HHEN. So it seems like we wrapped around a little bit. E to P Interesting, right? Interesting. I say we stop here. You guys really want to?
I wanna solve it.
Okay. All right, we'll solve it, guys. Cool. So now we can start to look at this code because we clearly can't figure out a pattern on our own. All right. So we have our string input and var1c, which looks like it's the count. So we can rename this to counter, and we can rename this to input. Right. Oh wait. Plus s. Yeah, that should be right. Input. Whoops. Cool. So now we're adding EAX plus EDX. And we know EDX is our counter. Cool. EAX was our input. And we're moving our input again. And then we're ANDing it with 0F. Moving it around, moving it around. And then ECX. So and then we're looping our counter. What are we getting from that? It's doing a lot of math. Alright, lots of man, you always got the best burgers, bro. Every time he comes into class, he's always got the best burgers.
Where'd you get that from?
That's a Jollibee's burger?
Wow.
Ah, man.
Bro,
Bro, that's a Chicken Joy? You're telling me that's a Chicken Joy?
yeah.
Wow, okay. We're getting Chicken Joys tonight. That's all I know. We're getting hella Chicken Joys.
Oh, so it's like counting the length of the letters, it's like running after each letter.
Something. It's doing something, right?
It's using the VHDEK whatever.
Using the VHD JEK by Pugmina. So we can call this VHD JEK. And throwing that into EAX. And we're saying EDX from before is this ANDed with 0F. ANDed with 0F. So if we put an A in this, 1, 2, 3, ooh. How many characters we got here? We've got 16 characters? Yeah? 16 characters? So this ANDing by 15 must mean something. Right? ANDing by 15 must mean something. So, we take A, and let's hop into Python. A and 15, whoops, char A, whoops, int A, is that what I want?
I guess you have to put CH8 on
Isn't that CHA?
Can't do bar?
I was just trying to get the value of A. Return as a Unicode. Yeah, did I not do this right? Okay. Oh, CHR. Ord. CHR is the other way. Okay, cool. My bad, guys. Something like that. Cool, so 97. So if we do ord A mod 15 or and 15, You get 1. You get 1. So now if we look at this list, 1, does it correspond to V or H? Corresponds to H. Okay, so if we do that, chord A and 15, we get H. You see how I did that magic? Right? Because it's coming back as 1, so we get H. So we know the next letter should be Y. And we split this up into 4s again. Y should be 9. So we want something and I, right? So chord 8 characters from A. H. And 15. We get 8. Cool. Let's plug it into this calculator thing we made.
Oh, I get it now.
Get it now, right?
Yeah, I get it.
Is this the official way we're supposed to do it? 'Cause this is not how we do it.
No! There's no right way to do it.
Okay, because that's me to program the bullshit in.
And that's a way to do it. Those are all valid ways to do it. There's never a right answer, right? In life, there's never a right answer. Right? If I get the answer faster than you, I got the answer faster than you. That matters sometimes. Matters a lot, actually. So now we're looking at our answer being AH, right? So we're looking to spell hyena, which I've already forgot. We're looking for E next. To get an E, we need the 1, 2, 3, 4, 5th character. So the 5th character from E. Is this right? Or should it be F? Yeah, okay. Cool, we'll drop it into this. So E becomes E in this case, which is really cool. Then we're looking for an N, should be the 16th character. What letter are we looking for here, guys? R?
What around the third letter?
I don't know.
The 16th letter of the alphabet.
No, I mean the letter looking for it.
Oh, we're on N for Nina. Let's try R. No, didn't work. We were kind of close. So it's not R. Let's try like S. Sorry, guys. Why don't we just take this up? Cool. So we're looking for an N. Lines up with P here. Let's try that. Chord P. And 15. That's 0. So let's go. Let's try L. Chord L. And 15. Does that track? I no. Comes after L. M. No. Okay. Looks like N makes an N. What the? So we got H E A H E N. A-H-E-N? A-H-E-N. And we need one last letter to get the A in hyena. It's the last one, yep. So we just gotta go over one more letter. Last one, so it looks like we can do O, right? And if we do an O here. Oh, A. Ahina. Run, yep. key now. And we hit continue. Oh, it exploded.
It's a D.
What is that?
It's a D, not an
It's a D.
E. A-H-D-N-O.
HD. What did we do wrong? HD. Did something wrong. I trusted. Cool. N-A or N-O?
N-O.
N-O works. Okay. Hmm. Hmm. Hmm.
Literally shakes out of all.
Hmm.
Just answer. I don't
Hmm.
know.
Why is this different?
I don't know.
Hmm.
They're bullshit.
It's been picked up before. Or maybe that mass character thing.
Well, the counter was involved somehow,
I just
right? And we
looked
didn't take
before,
track
so
of the counter.
It'll keep running few combinations using that character mapping until it finds one that matches.
Oh yeah, that's right. Hyena. Oh.
Because when you look in the code, it's looking for hyena, so you just gotta find whatever
Yeah.
it is after running through the alphabet that results in hyena.
Any questions, class? We're good with this one? A lot of math. So, level 6, super hard, right? Level 6. Looks hard. Based off the code, reading 6 numbers again. Right? Level 6 has a bug. Did you guys discover the bug? For level 6. What did you guys put as the answer?
It's ripping my hair off.
Oh, that's not it.
There's numbers. Actually, did you want the answers now or?
No. It just wasn't 00000. Okay. Now that we know that, let's take a look at it. So, we're reading 6 numbers. We have a comparison here of what looks to be our counter. So we'll name it counter. Awesome. We got a counter, it's gonna count. If we end up going down here, it explodes. If we end up going here, it explodes. So that's interesting. We can see 2 loops for our counter. You see a loop here, and what looks like a bigger loop here. And then even another loop here at the end, to get to the end. So that's kind of interesting. Let's see what our compares are. We have a compare for 5, we have a compare for 6, we have a normal compare, we have a compare down here before we explode. This one here, looks like it's comparing something. This one here, variable 28 is 0 f. Which is interesting. And then we have a counter comparison and just a comparison to EAX, which should be var plus 20, which is likely our input in this case. So let's set a breakpoint here. So let's delete 0 through 100, break, star, 0x. Run. Whee! Cool. Let's get to the end. All right, let's do 1, 2, 3, 4, 5, 6. And let's look at the input. So our input is 1. So that looks good, of EAX. And it's comparing itself to 6, which is bad. Automatically comparing itself to 6. These two, very interesting. Also have a test here. I continue here, we went to the same breakpoint, and we got to 2. So somehow we got to the next level. Hit continue again. Now we got to 3. Continue again. 4. 5. 6. We know that if it's greater than 6, it's gonna go this way, right? It doesn't say jump greater than or equal, so we should be good. So if I step into, I end up at 497E, which should be this one. And if I step into again, I end up at 4980, which is this one. So what does that tell us? What did we just learn right there? This specific function checks if number greater than 6. All right, this little thing right here, it just checks if any of our numbers are greater than 6. So from a brute force perspective, that sounds pretty good, right? We have 6 digits, can't be more than 6. How many combinations do we have? My mind wants to tell me 36, but I know that's wrong. 6 to the power of 6, right? Python can tell us that. 46,000 combinations, right? 100% brute forceable. 100% brute force. Always remember that. Everything's brute forceable. Sometimes. So we're going to check if numbers are greater than 6. So we know all our numbers are going to be less than 6. If it is less than 6, we're going to test it here, then we're going to come down over here, add 1 to our counter, then we're going to come up over here, which is going to compare our counter to number 5. We know from before that EAX should still be our input, so we're storing it in this var number 24. So I'm going to call this our input. Just because it came from over here, EAX never changed. It never changed as we went down. So we know that from before, EAX was our input. Comparing it with that, I'm going to put it there. Immediately put it back into EAX. And then we're storing that in EDX. Moving the counter to EAX. Cool. You know, we want to confirm something. If we enter a number greater than 6, does it blow up? Let's try 7, 5, 4, 3, 2, 1. Is that too many numbers? Cool, IR. You see 7 is the input, it should blow up, right? Boom, it blows up. So we know we confirm for sure that if it's greater than 7, we're going to blow up. So that's interesting. So we also know that this right here, this var 20, is input. So we have our counter, we have our input, and then we're comparing it here. So let's set a breakpoint here and see what that is. All right, cool. 1, 2, 3, 4, 5, 6 IR. So it's comparing 1 to 1. It's cool with that. Now it's comparing 2 to 1. Let's see if it's cool with that. Oh, it is. Now we're comparing 2 to 2. Ah. 2 to 2. Let's see if it's cool with that. It's not cool with that. Alright? So compared 2 to 1, 1 to 1, our input of 2 to 1, and then our input of 2 to 2. But our input wasn't 2 there. It's kind of weird, right? So we're coming through this.
I guess that's not like that compares to.
Something about what the compare is doing, right? So if it's not 0, we come down over here, which takes our input, stores it in EAX plus 8. Then moves our old input into over here. Right? So we're doing these weird things. And we come down over here, and we're doing something similar. Interesting. But at some point, we're blowing up. And it's likely that we're blowing up here. Right? So let's set a look back at this compare as well. Cool. Let's do 1, 2, 3, 4, 5, 6. IR. We get the 1-to-1. This new comparison that we're looking at, the 49cc. We got 29 in EAX. That's kind of interesting. Okay, let's continue. Got the 2-1. Now we got 2-2. And we know that based off of this, if it's below, we're gonna go to explode. So if we step into, oops, set this was, x/I $. We're at the jump not equal. We're at the move. So we ended up here. We didn't explode right away. Didn't explode right away. So that means we came back up here. Right? Because right now we're at C6, which is here. Oh, we're here. Oh, weird. Oh, we must have gone through this. Okay. Step into. Oh, now we're at the 99cc, which should be this one. 99cc, yeah. Cool. EAX 2 should be good. X/I $VIP. Jump below. So something here caused it to explode, right? Something here caused it to explode. Interesting. Thank you for using our demo version. So there's something going on here with our inputs. Yeah? know our counter EAX is important because it's iterating through some type of list. Right? There's some type of list that's going on here.
Looks like there's no end point, though. Technically.
No, there's an end.
Oh.
There's an end. This does end. We have this counter here of 5. So we can't go through this loop more than 5 times potentially. Alright. That's something that's there. Then we come into this loop and it comes down and it iterates. Iterates. Doesn't stop. What if we try some different numbers? Try 6, 5, 4, 3, 2, 1. IR, we got 6, we're good. Comparing it to 1 though. Alright. 6, 2, okay. 6, 3, 6, 4. 6, 5. 6, 6. Now we got this weird number. Now we got our 5. 2. 3. 5. Looks good. I don't really know what's going on. It's really going through the program though. At some point the bomb exploded. So we're getting kind of closer. We're at 4. Any thoughts? Any thoughts? What should be our answer here? Cool. Python is our answer here. For I in range 0 through 6. For I 1. For I 2, for I 3, for I 4, for I 5. 1, 2, 3, 4, 5, 6. Cool, right? Now we got this. What are we gonna do with this? We're gonna brute force it, right? How are we gonna brute force it? Process, open, Python. Nope. Process run with input. Multiprocessing? No. Input. I thought I made this really hard. Couple different ways we can do it. I'm gonna put out this. That kind of works, right? We have some type of thing there. Yeah? Some type of thing there. You do something like try this. New file, test.py. Import, we're gonna do /bomb. Our input should be this. Just bear with me. Gonna do a multi-line comment. Or actually, it's probably better if we do this. /n/n/n/n/n/n. Cool. Python test.py. Let's do that. Hanging for input now. So let's try echo stuff. Hate how they made this nowadays. Really hard to use subprocess in Python, especially when you're an idiot. Dun, dun, dun. read line. And we're gonna write code never bothered me anyway. New line. And then read line. Tell me this is right on two. God damn. Jesus. I hate the world so much.
Python 7 and Java are really these days.
What was that?
Python 7 and Java these days.
Yeah.
Okay.
I guess we gotta do Python 3 sub process. Ah, cool. And let's getting closer. Cool. So now we're at the point where we can input some random characters. So, let me just think of it. Plus stirs plus stir I
When you put in this I2, it's just printing I2 instead of the A for I2.
Yes. Yes.
How'd you pull that off? What?
Oh no, like all that check marks over there.
I don't know, we did it and it was fucking broken.
Yeah.
Number 5 put like 20 million check marks on the board. I was like, bro, what the? Wow.
Oh, that's it.
Oh, yeah, fix it. It looks like a freaking egg. It's funny when you do it initially.
You want to keep the attention right for that, I guess.
I don't know.
Nice. Nice. F.
Yeah, I get extra points, I don't put on check marks.
How many you solved one time? All of them. All of them. How the fuck?
I would put more answers than there was questions.
Why?
Right? Quiz?
Okay.
I didn't do it. Stop it right.
Charlie P set up again.